If you've ever watched your AI agent just spin its wheels for what feels like forever, only to spit out a confused hallucination, yeah, we've all been there. Welcome to today's Explainer. We are tackling a massive leap forward in how we build AI apps. We're talking about the critical shift from relying on just one single AI agent to orchestrating parallel multi-agent teams using the coordinator worker pattern. So if you're looking to scale up your capabilities and seriously cut down on processing time, you are in exactly the right place. Okay, here's our roadmap for today. We're looking at the single agent ceiling, the coordinator worker solution, 3 big architectural wins, a concrete cloud example, and finally, the over-decomposition warning. Let's get right into it. Section 1, the single agent ceiling. Now, to understand why your builds might be hitting a wall, we first got to look at the foundation, the React loop. Reason, act, observe, and repeat. It's brilliant, right? For a single agent tackling one isolated problem step by step, it is the absolute bedrock of modern agent design. But when you start pushing it too hard, that's where things get messy.
And here is the exact bottleneck. When you ask that single React agent to juggle multiple, completely unrelated tasks, you're literally forcing a parallel problem into a sequential pipeline. Everything gets shoved into one slow, single-file line. It creates a massive logic traffic jam in your app. Think about it. You ask a solo worker to research 3 different topics. It has to do them one by one, all inside the exact same reasoning loop. Every new piece of info just gets crammed into the same context window. The agent loses track, context window bloat sets in, and boom, it gets confused halfway through topic 2. The whole chain completely collapses. Which brings us to section 2. The coordinator worker solution. So what's the fix? Well, we split the responsibility instead of stacking it. We're moving away from that stressed-out solo worker trying to do it all in a strict order, and we're bringing in a coordinator. This coordinator is basically your manager. Its sole job is to take the big incoming task, break it down, and delegate the pieces to a team of specialized workers. Here's how it actually plays out mechanically. The coordinator grabs the massive task and shatters it into independent subtasks. Then the workers step up. Each worker gets a very narrow, super specific job and, this is absolutely crucial, its own clean, empty context window. They run concurrently, all at the exact same time, completely oblivious to what the other workers are doing. Finally, they hand their finished work back to the coordinator, who synthesizes it all into one polished answer. Moving right along to section 3. 3 big architectural wins. Win number 1 is a no-brainer. Speed. Because your workers are grinding away in parallel instead of waiting in line, you aren't waiting for task A to finish before task B can even start. You see a dramatic drop in total wall clock time. A task that used to take minutes of painful sequential reasoning literally gets slashed down to just the handful of seconds it takes to run your longest single subtask. Win number 2, focus. Like we talked about, solo agents suffer from context bloat. But with this pattern, each worker only sees what it needs to see for its tiny, specific subtask. The context stays totally clean and isolated. This basically eliminates the context drift and hallucinations that ruin long React chains. And win number 3 is specialization. Since these workers are totally independent, nothing is stopping you from giving them completely unique loadouts. You can arm them with different tools, custom system prompts, or even entirely different AI models tailored perfectly for the job. You could have one worker browsing the web while another worker right next to it is crunching Python code. So, just to recap these wins, you get parallel speed, razor-sharp focus, and custom specialization. If you're chasing reliability and performance in your apps, moving to this team model is, for sure, an absolute game changer. Let's look at how this actually works. Section 4, a concrete cloud example. Let's ground this theory. Imagine a user drops this prompt into your app. Write a comparison report on 3 cloud providers' pricing for GPU instances. Giving that to one single agent? Absolute bloated nightmare. Let's see how our coordinator handles it. First up, decomposition. The coordinator outputs a structured plan, breaking the prompt into 3 independent research questions, 1 for each cloud provider. Next, dispatch. It fans out the workload, launching 3 worker agents at the exact same time, maybe using async tasks or a thread pool. And finally, aggregation. The coordinator grabs those 3 independent summaries, double-checks them for consistency, and stitches them into a final unified report.
And what's so cool here is that each individual worker is just running its own mini React loop. It reasons, it searches, it observes. But its entire universe is strictly limited to its one assigned cloud provider. They don't care about each other's progress. They just nail their specific job and hand a crisp summary back to the boss. Now, if you're writing this in code, say using a framework like LangGraph, the architecture is just gorgeous. It maps perfectly to a graph structure. You start with one coordinator node, fan out to your parallel worker nodes, and then all those paths emerge back together at a join point for the final synthesis. It is such an elegant, scalable way to build. But wait, before you go, rewrite everything. Section 5, the Over-Decomposition Warning. You have to judge your tasks accurately. If worker 2 absolutely needs the answer from worker 1 before it can even start thinking, well, you don't have a coordinator worker problem, you have a sequential problem. Forcing parallelism onto tasks that depend on each other is just going to give you broken, contradictory garbage because the workers simply won't have the context they need. So, the golden rule: this manager and team setup only pays off when the subtasks are genuinely separable. If a task naturally splits into independent pieces, use this pattern. If it doesn't, stick to the standard React loop. Don't try to cram a sequential problem into a parallel architecture. It just doesn't work. All right, let's wrap this explainer up. Remember, the React loop is still your foundational building block. The coordinator worker pattern simply takes that loop and multiplies it across a delegated team. Stick to genuinely independent pieces of work, and you are going to get significantly faster, cleaner, and way more focused reasoning. So I'm going to leave you with this to chew on for your next build. Take a hard look at your current AI pipelines. Which of your slow, bloated, sequential tasks is actually just begging to be managed by a parallel team? Find those bottlenecks, bring in a coordinator, and watch your app's performance absolutely soar. Thanks for hanging out with us for this explainer, and happy building.